Hey everybody, this is Activities Across Grade Levels, and today we're going to be talking about some astronomy, all kinds of different ways to get kids to reach for the stars. All right, so what we're looking to do is to get kids kind of in that space where they are beginning to see new possibilities for themselves. And usually I just have Rushton, don't forget to draw on the captions, but we're working with a guest today and I'm getting excited to introduce him here in a moment. But let me also say that we have our next episode on March the 18th. It's called Fun Feedback. Get it? Fun feedback. Anyway, so in terms of how do you get kids thinking about ideas for sharing possibilities with each other, or for kind of talking about critique in interesting ways, accepting the idea that there's different kinds of things that can make what they do better, the idea that they should improve their work rather than just be like, but I've already done it, right? Those kinds of things. That's what we're going to talk about on the 18th. We hope you will join us. Next Vista for Learning is my own little shindig and a thing that I've got with the hope that it'll save the universe from ignorance, one creative video at a time. Loads and loads of videos by and for teachers and students everywhere, and we hope that you will give that a look. We're doing some contests right now to beef up that little library. One of them is called Creative Recovery 21. 90 seconds or less creatively explain something one might encounter in school. And that could be, for example, what a light year is. See what I did there? All right, and try to just get something out there in such a way, in just this little chunk, that allows the kid to go, oh, wow. Or if it was something that has been giving them trouble, that video would allow them to say, I think I can get it now, rather than I'm no good at math, writing, whatever it may be. Service via video is all about telling the stories of those who make life better for others. And we hope that there are plenty of people in your community who could be helped by students telling their story in a short video. Maybe help them get new supporters and volunteers and all such things. So please give this a look. You'll be able to click on these slides once you get the slides, because having registered for this, I will send you the slides. Thank you for being a part of what we're doing today. And thank you to the KCI in Los Altos Hills, the Krause Center for Innovation at Foothill College, the Merit Program, all the good things that happen with that, and the new ELLI program, Emerging Leaders in Learning Innovation, ELLI. And we are excited about what that is going to be for those who have been through the Merit Program. Much more about that if you contact me and ask. And a thanks to Fowler USD. And if you are not familiar with Fowler USD, Susan, why don't you tell us a little bit about what Fowler USD is and is about?
Oh, yes. We are a small school district in Central California, a rural farming community just south of Fresno. We have 2,600 amazing students and 126 fabulous teachers who are doing our best to keep the learning going during this crazy time. But I am really excited to be able to share these resources and just share the learning with my awesome teachers from Fowler.
Awesome. And a thank you goes out to Richard Byrne, who is the person I work with on the Two EdTech Guys Take Questions and Share Cool Stuff webinar, which happens on the same days we do this, but earlier in the day. That recording from earlier today is already up. We hope you'll give it a look as well. Now, we are very happy to meet you. So let's start with a little bit of introduction. Susan, who would you be?
So yes, my name is Susan Stewart. I'm an instructional technology coach and leader in Fowler Unified School District. I am a mother of 3 fabulous kids and a former kindergarten and second grade teacher. So I spent a lot of time teaching young learners, and now I get to support K-12 teachers in all things. My job title is other duties as assigned, but my primary role is helping teachers, and I really enjoy being able to do that in whatever way they need.
Nice. My name is Rushton. I am a former high school teacher of Japanese language, a former principal of a K-12 school, principal of an online high school, and now I run that little nonprofit I told you about earlier. And we have a buddy with us today, and I am excited to introduce Andrew. So Andrew, tell us a little bit about yourself and what's going on in these pictures.
Yeah, so hello. I sometimes introduce myself as a recovering astronomer because I pursued a passion in astronomy, and then in grad school really discovered that my true passion was in teaching. And so became a high school teacher and then discovered the world of online learning, where I've worked for the past decade. Telescopes are big when you can walk on them. And that's why I have that picture of myself on one of the larger telescopes that have experienced. But currently, I work as an online astronomy teacher, working with community colleges scattered around the country. And so everything I'm going to share with you today, I actually use with college students. And what excites me about what Rushton and Susan are doing is illustrating how these same tools can be used at so many different grade levels in so many different ways. And so I hope we can see that together in this particular field of astronomy.
Wonderful. Now, how is this going to work today? Well, our usual pattern is to say, all right, so any given theme, how does that look for the K2 crowd? How does it look for the 3rd to 5th graders? How does it look for the middle schoolers? How does it look for the high schoolers? And along the way, hopefully you'll look at these different ideas that are being shared and say, you know, I might be able to use that with my group, even though my group is a different group than the one that's being characterized at the moment. So with that, I will hand it over to Andrew to take us through a different set of grade groups as we go along, and we can learn a little bit about possibilities for astronomy with each. Andrew, get us going. And you're muted.
I'm muted. Sorry. Can you see my screen all right?
Looking good.
Great. Then, yeah, so I'm excited to start off with young learners. And in each of these cases, we're going to look at a tool. And again, I use these with my college students, but I hope that only sort of sparks your imagination of how these tools can be used at so many grade levels. I've used Stellarium personally with 6-year-olds. And here's the idea. Stellarium Web is a free tool, and it's what you call a planetarium software. So it simulates the entire night sky, and it's completely interactive. You can click and drag around and move and see the whole sky. And not only that, you can click on any object in the sky, and it gives you all kinds of interesting information. Now, a lot of that is irrelevant for younger learners, but I hope you can see that there is a depth to this software that actually is incredibly powerful. The way I use it, though, is in lots of different ways with younger students. I'll ask and see if they can find like bright planets. I'll ask, I mean, honestly, you just make time go forward and it spins around in amazing ways. And it's like just exploration and discovery at a young age, in my view. But certainly you can turn on constellations and give students a chance to find things they might recognize. You can even turn on the constellation artwork so that students can see what those constellations are supposed to represent. My personal favorite thing is you can change to any location in the world. So you can explore what the night sky looks like tonight from the North Pole or the South Pole or anywhere in the world. And what's most exciting is you can change it to any time in history. And so I often invite students to look up what does the night sky look like on your birthday, or the day that is the day you were born, right? Because you can change the actual year, month, and day. And of course, you can move forward and backward in time to see how things are changing. What's also really cool about this for younger learners is it's almost like a virtual telescope, because you can zoom in with your scroll mouse tool and you can actually see what these objects look like up close. And as you go forward and backward in time, you can even see, for example, Jupiter's moons moving around it in orbit, just like you would if you could look at it through a telescope over the course of several hours. You can even see galaxies. You can zoom way in and see all kinds of amazing details. Just as an illustration of how powerful this is the actual activity I use with my college students. And I know it's not a great fit for younger learners, but again, it's just stretching our imaginations. What we do is we look at several Van Gogh paintings and we go back to the same location and day when he's believed to have, sort of captured that mental image. And we compare the painting to the night sky to see what are the objects. And in this case, actually, the crescent moon with Venus, and maybe most people don't even notice here, this fainter star is actually the planet Mercury. And so students can compare that artwork to the actual night sky. So I have just a little capture here so you can see what it looks like in action. But I thought I would just throw that brief introduction out to Susan and Rushton and see if this sparks any thoughts for younger learners.
Oh, I really do love this. And one thing I do love about it is what you said about there, that just kind of like inquiry and play. Maybe they don't have all the, can't read all the captions or read all that, but just that ability to zoom and twist and turn and kind of touch and interact with it. I love that, because that's where it starts, right? Just that opportunity to kind of dig in and be interactive with the content. We can, start having them ask questions then at that point. Once they play, what do you notice? What do you see? What do you wonder? But it can all just start with a little bit of time, tinkering in a tool like that. So that's very cool. Thank you for sharing that.
Yeah, and taking, for example, constellations and just talking about shapes, right? So getting them, from this is what this is. You can recognize what a triangle is, blah blah blah. But also just beginning to think about, what are the shapes you see around you when you look at Orion and a belt, right? How does that work? What kind of shape do you need to put, this together, that together? Maybe a bit of a stretch for the youngest kiddos, but certainly getting them thinking about what they see and that, what do you notice? What do you wonder?
That's awesome. I appreciate it, guys. And one of the sort of playful activities I've done with students as well is to show them a cluster of stars, a group of stars, and encourage them to make their own constellations and even their own stories that go along with those, as we just kind of look a little bit at the history of all the different cultures having their own unique constellations. There's a lot that can be explored across the curriculum.
I like the idea of a constellation for their pets.
Nice. Fill the sky with all their pets. So wonderful. Well, let's see. I would like to move on and show you guys another awesome tool that I've used with students over the years. This is Google Moon and Google Mars. And again, I really think each of these tools can be used truly K-12 and beyond. But I kind of targeted upper elementary for this because I think there's a lot of cool connections, especially that's where we're learning about the solar system a lot. So I don't know if you know this, but Google has a moon map, which is just like Google Maps in that you can click and drag all around it. And you'll see these buttons here. It says Apollo, Visible, and Elevation. So there's actually different displays. So for example, elevation is showing laser altimeter data that actually shows the relative height and lower levels. But you can just like Google Maps, you can zoom in and navigate around this and explore the lunar surface. And there's all kinds of really cool things to do. I use this when I'm introducing terminology, right? And showing examples to students. So I'll show them example for if we're learning about the moon, the maria of the moon are these darker surfaces on the left where it's smooth and there are fewer craters. Those are more recently made surfaces on the moon. And on the right, I might show them these striations, these like radial lines coming out of that crater, which are known as rays. And once I show that to them, I can then send them loose exploring the surface of the moon and ask them to find other examples of those same features. So I think that's kind of a powerful tool. One of my favorite things, though, is that the Apollo map, you may have noticed, has these little weird blocks where things look a little different. And if you were to count how many of those weird blocks there are, it actually corresponds to the number of Apollo missions. Because if you zoom in on those blocks, you can actually see that you get higher and higher resolution images as you go deeper and deeper in. And what that actually is showing you is Apollo landing sites. And so you'll see here, this is actually the Apollo 16 landing site. And you can see the astronauts went over to the Flag crater. And then you can pull up an actual image from the Apollo mission of Flag crater. And it just makes this amazing connection for students between what we see from these sort of satellite-like images to what it was like for astronauts actually on the moon. What's really cool is there's a very similar tool for Mars. So this is actually Google Mars, and it has the exact same features. You can navigate around, there's multiple maps, you can zoom in and explore, and I use it in much the same way. Here's the visible map, right? It's black and white, but it shows what it looks like to the human eye, and here's infrared, which is higher resolution. And one of the cooler things about Google Mars is that it has these links in the upper left-hand corner. So for example, you can click on spacecraft and it'll show you every spacecraft that's ever landed on Mars and its location. And it's only showing 7 of them because they don't all fit on one page. But when you click on them, it'll even tell you information about that. Likewise, it has information about dunes and rifts and craters, and it'll mark them and give you special information about them. So again, when it comes to exploration, it kind of helps you find the most interesting points on the surface of Mars. In the case of Perseverance here, of course, very relevant today, it shows its exact location. And just like with the Apollo example, you could show students those, that landing site and then pull up the images that were captured. Literally, this one was captured 2 days ago from that spacecraft at that location. It's just an incredible, really just the analog between Google Earth or Google Maps where you have Street View. It's like we literally have that for these other places in the solar system. The way I use this as well as to introduce, like, I think this is a powerful example as we talk about water on Mars, which is always talked about as a science justification for missions to Mars. And from these images, you can ask students to simply explore and say, do you see any evidence of water? Just from these satellite images. And you can see this image right here shows clearly, and it's not hard to find it if you look, it shows clearly what look like river channels. And like I said, they're not hard to find. And I think it's really striking that students can see that for themselves, make their own observations, exploring. So I don't know if this is appropriate for upper elementary. I'm curious again to kind of solicit what Susan and Rushton think about these tools at that age group.
I think they're absolutely appropriate. I think just putting them in their hands and knowing that there's a lot of content there. So like anything, we want to make sure the students are in a place that you're going to click on things and make sure that what they find is appropriate, but like knowing that this is a Google tool, knowing that it's coming out of the Google content there, I think it's absolutely appropriate for those kiddos and just giving them those opportunities to be able to click and explore and go further. I think what you've done here with us is kind of taking some time to explain how to access the content and the different kinds of content, as far as how to do the zooming and how to, the different, like the infrared is higher resolution. And if you get closer, you get to see these things. Taking some time with those elementary learners will be important to kind of equip them with a more efficient tool. Like with the young learners, it's just go play with it, right? But some directed exploration, maybe some modeled exploration would absolutely lend itself to kids having some meaningful exploration on their own beyond that, for sure.
I also like that that this is going to be something that they might well have heard about in the last couple of weeks. The whole perseverance piece, right? Just last week, I was doing a program with some fifth graders in St. Louis, and we used a video that is it's an animated video from NASA explaining that's showing what it is that's supposed to have happened, right? And largely did. Are you going to mention that particular video later? If not, I'll toss it into the chat right now.
You go right ahead.
Boom, there it is. Okay, speaking of going right ahead, take us into the middle school group.
Yeah, absolutely. Oh, and I'll just throw out there that I'll often, when I'm teaching online, right, I'll create a 6 to 10 minute video where I'm showing specific examples using Google Mars, and then again setting or Google Moon, and then setting the students loose on doing it themselves. So for middle school, this is a lab I created based on observations I made as a college student, and I call this the Asteroid Discovery Lab. And it's just a little web page I put together where there's a series of animated GIFs, and these are real astronomical images captured through a telescope. All of the dots you see are stars, and there were 4 pictures that are playing in a loop, and they were taken about an hour apart. And what's really exciting here is you can see an asteroid moving in this image. And so again, I create a video that explains what all the other little pops and ghosty things are in this image and what you can ignore, but how to look for something that is truly an asteroid. And these images were actually used to discover new asteroids. So I discovered an asteroid sort of quite by accident, and then we realized how it could be repeated. And so so the college I went to has since discovered something like 500 asteroids after I discovered this first one by accident. And so it's a great activity for students to see what the nature of discovery really looks like. Here's another field, and you can see this. There's an asteroid right there. There's an asteroid right there. There's an asteroid over on the right-hand side. This one I think has 6 asteroids in it. And I love at every opportunity, and you'll see what's already happened with Google Mars and Google Moon, and now this is giving real astronomical data in students' hands, giving them a chance to really experience what data is really like. The way I do this with students is I print off a negative version of the image, so to save ink, and have them simply mark where they see asteroids in the field, right? I'm also a big fan of sort of visual assessment. It's like, why have students write a lot when they could just show me with a picture or a drawing? And it also is easier to grade, but so it's just a simple assessment tool that I use. I had to throw in a bonus for middle school though. This is like, an example of hands-on learning, especially as an online teacher. It's really challenging to get astronomical equipment in students' hands, right? They can't have telescopes at the grocery store that they can just buy. But what they can find generally is a cereal box and some aluminum foil and a CD, although that's becoming harder to find these days. And with those simple tools, students are able to make their own spectrometer. And I've had good success with this, where this is actually one of my college students who was able to capture an image of a spectrum. Now, this is just like a simple rainbow of a regular light bulb, but you can actually get pretty impressive spectrum with such a simple tool. And so especially when getting the right equipment can be hard, like a diffraction grating is what you would need normally, but the CD can serve as that. Anyway, it's a fun activity that I think would be well suited to middle schoolers, but it also works well for me as an online instructor. Susan, Russian, anything you want to add to these middle school activities?
I would say that actually talking about a spectrometer is a good avenue into talking about specialized equipment, right? Because that doesn't tend to be on a kid's radar for quite a while, typically. And being able to say, well, what are, if you're making a list of specialized equipment that you know how to use, what would we put on it? And being able to say, all right, so you know what a spectrometer is, and just get a kid in a mode where they can go home and say, Mom, do you know what a spectrometer is? Dad, do you know? And they're like, not really. Why don't you tell us? And that's a moment where the kid can share something really, really cool and get that sense of I'm capable of teaching other people things.
That's great. And I love, everyone has the experience of looking at a disc and seeing that rainbow, and this like connects it both to understanding light and how that tool can be used to understand the universe. It does fit closely with topics that are generally taught in a middle school astronomy setting. For high school, I'm showing sort of a classic simulation. This is actually another one I've modified and put it up on my website. And this is exploring Kepler's laws, which is an advanced topic, but I've also used this exact same tool again with like kindergarten and first graders. And Kepler's laws are the laws that describe orbits and gravitational orbits. And what I love about this tool is that you can just play with it to build an intuition for how gravity works. And because it works in a way that's not necessarily intuitive. So one of the first things it allows you to do is just try to throw a planet and try to get it to orbit, which is not always as easy as it seems. And one of the first things that students notice is that when planets do orbit, they orbit in ovals, which is actually Kepler's first law. The features of the simulator allow you then to change other things, like so that you can just trigger planets to be created with specific orbital characteristics. And so you can challenge students to make certain types of solar systems. Like I want a solar system with 5 planets that do this or that. It also has some more sophisticated features like creating an entire solar system from debris fields. So this is called the solar nebula. And this is actually, you can see the planets are merging with each other. So this is actually truly simulating the formation of a solar system. Or you can even trigger a fully developed solar system where you can see like a moon is orbiting a planet. And so again, as an exploration tool, building intuition, it's just plain fun. I've, like I said, had young students who just played with it for like 20 minutes, just kind of like, hey, look at what I just made, check this thing out. What I'm excited about at the high school level and beyond is that it actually is a legit simulator. So I can actually have students recreate the orbits of very specific objects in the solar system, like the Earth, Mars, or these asteroids. And they can actually use the timer that's built in to measure the orbital period. So I've calibrated the simulation so that it actually is accurate. And then we use that to test Kepler's third law, which is an equation. And so again, I think this is an example of a tool which, in one application can be used for exploration and discovery. And at the other end, it can be used for sort of sophisticated understanding. I invite you guys to add anything else that you'd like to add, but those are the tools I was hoping to share with you guys today.
Very cool. So an astronomy question for you, and thinking
Yeah.
back to the Kepler's, the Kepler simulation that you showed. I was reading something recently about trying to get objects farther out into the solar system, and they all seem to kind of be built around if you want to build speeds that are beginning to approach the speed of light or anything close. It kind of requires gravity. Is that something that can work into a lesson related to what you were using just now?
Yeah, definitely. In fact, so you call it gravitational assists. And one of the things you'll notice when you play with that for a while is you start accidentally ejecting things from the solar system, where two planets will just fly too close to each other and one of them will just take off going the other way. And so it's a really cool, it's really cool. You end up discovering things that actually happen in our own solar system.
Fantastic. Susan, any last thoughts from you before we do the wind down on the recording?
I really love this, because what we were talking about earlier about when kids come home and they have something that they've sparked an interest. Oftentimes something like outer space literally feels like outer space. It's something they can't connect to or with which they don't have any context or experiences. So by giving them access to these tools just to tinker and play and become familiar, you might find those one or two kiddos who are like, yeah, this is for me, and really gets them started and empowers them into knowing that it's attainable, right? It's within their reach. And something like building the tools themselves or just becoming more familiar with the tools, you've got to spark that little light and just put it in their hands, and you can be amazed with what they do and go with it from there. And then whatever curiosities are sparked will just grow. And it's just like anything that we introduce to kids, it's like coding. It's not going to be for everyone. Not everyone's going to be like, oh, this is for me. Well, with space, it's going to be like, you're going to find those people. But just by having these simple tools that are really accessible to everyone and putting them out there, it's exciting because everyone gets the introduction, but how easy it is for the ones who want to go further. Like there's not an end to that lesson. That could just go and go and go. So we start in that, everyone can have a learning experience here, but how much deeper can it go for the ones who really do find a passion in this area?
Yeah, I just have to add, as a teacher sort of young students, and high schoolers, that was my experience. The Holy Grail is like when the student goes home and is sitting around the table and tells their parents about this cool thing they learned. And I have to tell you, now I'm a community college professor and I teach a lot of adult learners. And I get emails from my students who say, this was so cool. I showed my kids. I'm doing it with my kids. They love it too. And that's something that's such an awesome inverse when the parent is excited about learning and then brings it to their child and the child gets excited. So to see families joining together in this learning is really is what I live for in this.
Very cool stuff. Well, let's wind things down before we stop the recording and I ask more questions about space, which will be the next thing that happens after that. As we like to tell everybody who watches our recordings, whether live now or on the site, nextvista.org has all of now this will be our 35th episode of activities across grade levels. And we love sharing cool ideas in this fashion, but take good care of yourself. If you're going to be that teacher who can help a kid make a connection at a moment when it's needed. We have to have our wits about us, we have to be as rested as possible. All kind of hard to do, right? But get that sleep, eat right, do all those things. Now, make sure to take a look at the newsletter possibility. I mean, if you have not looked at one of our newsletters before, we hope you will. All free to use. We'll make sure in the links too that you can make your way to the March one. We've got a blog at rushtonh.com, rushtonh.com, and hopefully plenty of ideas there that will be useful for you. Got some books, happy to talk to you about their possibilities for helping your people see new possibilities for themselves. And if you want to contact Andrew, we have got his email address right there on the links page for you to follow, or you can go to this slide and click on his the yellow email address and you are on your way. Susan, why don't you wind us down by telling how people can stay in touch with you?
Oh, you can find me on the internet on Twitter at Tech Coach Susan, because I'm Susan and I'm a tech coach. And also follow things I share and things I am passionate about. And that is under the hashtag K2Can2, because we're all about trying to empower our littlest learners with just meaningful learning experiences. So yeah, absolutely. Tech Coach Susan on the Twitters.
All right. And Andrew, any kind of last comments about how people might work with any of the information you have provided?
I'm always interested in new and exciting stuff. So, if people have questions, I'm here. I'm here to answer any questions or have a conversation. So feel free to reach out.
Excellent. So with that, I would like you to watch for an email from me, which will have the link to where we hold the recordings for all of these shows. For each one, we also provide the link to the slides and to the links that we mention, all of the different tools that Andrew mentioned, we've got in that links page. And we would love for you to use those to find a way to inspire your students. And with that, we would like to finish up. And if you are with us live, feel free to stick around for some more questions, because that's one of the fun things that happens from joining us in this fashion. Have a wonderful weekend, and we'll see you in 2 weeks.